This video is about multiple representation. So we're going to create function rules and evaluate situations and interpret multiple representations of a situation. So in the first one, the girls volleyball team is having the end of the year banquet. They found a banquet hall they can rent for $400 plus $12 per person to eat. Create a concrete, graphic, numeric, and algebraic representation of the situation. Put a dependency statement in the diamond. So first we're going to look at a concrete representation of the situation where it says give two examples. So let's draw what happens if we had one person that would go to the banquet. And let's say we have 5 people going to the banquet. We can pick any kind of numbers. So I'm just going to pick something that's small enough to draw but gets the point across. So in this case, remember that they're renting a building. So I'm going to draw a little building with a door and a window. And I know that that was $400 for them to rent, plus I have one person going to the dinner. If I have 5 people, I'm still only renting the building once, so I'm only paying $400 once. Plus I have 5 people that would be attending the banquet. Then we can move to our numeric representation. So in our numeric representation, we're creating a table to represent different values. So if we have 15 people that go, it costs $400 to rent the building plus $12 per person to eat. So when I multiply that, I have 12 times 15 and 12 times 15 is 180 plus 400 would get us $580. If I have 30 people attending, it's $400 plus 12 times 30 people, so 12 times 30 is 360 plus 400 gets us $760. If I have 45 people attending, it costs me $400 plus $12 times the 45 people, so 12 times 45 is 540 plus 400 costs us $940. Remember in the diamond, we need to write a dependency statement. So completing a table and drawing a picture can help us with our dependency statements. Remember when we have a dependency statement, it is the independent variable depends on the dependent variable. Your table can also help you identify the independent and dependent. So remember the independent is the input to our equation. So in this case, the number of people. Our dependent is what we're trying to figure out. So in this case, the cost. So in here, in our diamond, we would say the cost depends on the number of people attending the banquet. Or we can just say people attending. Next, we have an algebraic representation. So in an algebraic representation, remember you need to do 2 things. First, you need to identify your variables to tell us what we're using. And then we also need equations. So in this case, we're looking at number of people. So we're going to use P for people or person and C for cost because we're trying to figure out how much money they have to spend on the banquet. So because cost was our dependent variable, we're going to have C equals $400 for the service fee plus 12p, which means $12 per person. Now we're going to do a graph to represent the table from above. So remember the table above, our input was what's going to go on the x-axis, which in this case is people. And in our table, we had 15 people, 30 people, and 45 people. Because that goes up by increments of 15, we can spread out our graph going in increments of 15. Now, when I go up the x-axis or the y-axis, we know the y-axis is representing our cost. If we go back and look at the table, notice that our cost is not really starting until 580 because of the information we are given. We also know that the service charge was 400. So that's really the smallest number that we are dealing with. So in our table, we have 2 options. We can either go by hundreds or we can skip to 40 and add our little broken line. So if we have a broken line on our graph, we can show that we skip some numbers, and then we can start at 400 and increase by 500s or by 50s. So I'm going to go by hundreds. We could also use 50 though. So I'm going to go by hundreds though. So then I need to plot my points. So I know that this point's not in the table, but I know that at 0, 400, that's my service charge. So I'm going to add that point to my graph. For 15 people, it was 580, so we're just going to kind of estimate on our graph. For 30 people, it was 760. And for 45 people, it was 940. Now, in this case on the graph, we're not going to connect our dots because we can't have partial people attending, so we can't have a straight line because it's not a continuous graph. We do, however, need a title on our graph, which this one we can call the volleyball banquet. Kind of describes what this problem is about. So let's try another multiple representation. Number 2, Brandon wants to make a sandbox castle in his yard. He discovers that sand is ordered in yards. A yard is 1 cubic feet of sand. The Burlington Sand and Gravel Company charges $23 per yard, plus the additional $45 to deliver the sand. Create a concrete representation, graphic representation, numeric representation, algebraic representation of the situation. Put the dependency statement in the diamond. So, concrete example. So for a concrete example, let's say what happens if he ordered 1 yard and if he ordered 5 yards. So if he ordered 1 yard, we have our delivery truck bringing it for $45, and we have our 1 yard of sand. If we order 5 yards, we still only have 1 delivery truck coming. That's going to cost us $45 for the delivery fee of the sand. And then we have 5 yards of sand. So 1, 2, 3, 4, 5. The numeric representation, remember, is our table again. So in the numeric representation, we have to pay $45 for the delivery, plus we have to pay $23 for every yard that we order. So in this case, we would have a cost of $68. If we order 5 yards, we have $45 plus 23 times 5 yards. So 23 times 5 is $115 plus 45 gets us $160 for our cost. If we have 10 yards, $45 plus 23 times 10. So 23 times 10 is $230 plus $45 is $275. So now we can write our dependency statement. So remember the dependency statement? Look in the table, that will help you again. The input is your independent variable. The dependent is the outcome or the output variable. So in this case, we would say the cost of sand for the sandbox depends on the number of yards of sand ordered. So in algebraic representation, we need 2 things again. We need our variable. So remember, we have y because we're ordering yards of sand. And we have c for our cost. So in this case, the dependent variable goes by itself. So cost equals, we're paying $45 for a delivery fee plus $23 per yards of sand, so 23y. Then we can move to our last part, which is our graphic organizer. So in our graphic representation, remember that the x is the yards of sand. And in this case, we can just go by ones because we're only going up to 10. Remember that you should have about the same spacing because we're trying to make it look like a graph. and graphs have to have accurate scales. Then we also have cost. So now if we think back to cost and look at our cost numbers, they're relatively close together, a couple 50 or a couple of different tens places off. So we're just going to go up by a smaller increment than the last problem. So we're going to go up by 50s. We also don't really have to skip numbers because our highest number in this case is 275. So when I'm picking a scale, I'm going to go up by 50s. So I have 50, 100, 150, 200, 250, 300. Now, in this case, I don't want to include the data point 045 because if I don't order any sand, it's not something that I want to pay for. I'm not going to have a truck just show up at my house delivering me nothing. So I don't want to include that data point. So our first data point was 168. Remember, we're just kind of going to estimate. Then we had 5 160. And then we had 10 yards of sand for 275. Again, we're not connecting the line here because we can't order partial yards of sand. We're only going to order full yards of sand. And then our title to our graph, we could say sand for sandbox.